Okay folks, welcome back. It is Siberian, and I figured I'd give you guys an update on the Sentra ITB project. I know it's been quite a while. I've been pretty busy. A bunch of life things have kind of happened again as I do. I'm not going to really get into that too much, but what I did want to talk to you guys about is that I've decided to kind of move away from 3D scanning the original kind of intake manifold for the Sentra, and instead I decided to just kind of make an airbox or plenum for the ITBs sort of on my own. Now I found this particular part on some 3D site. I can't really recall the name now. It's been sort of a while, and basically I'm going to be modifying this part to suit our needs. One of the first things that I did here is I removed the collar that would typically connect to the throttle body, because obviously our throttle bodies are now going to be down here instead. So this will allow you to mount, basically your typical sentra intake onto this section here, which means we'll still have the MAF out in this section, kind of measuring the air. Then moving forward, as you can see, there's this little clips right here. So this thing will eventually come apart in two pieces, so you'll be able to do some cleaning on the throttle bodies, or if you decide to alter the velocity stacks or what have you, you'll be able to do that as well by unclipping the bottom section. And then as you can see in here, I've emptied these out right now because by default it had kind of a different design meant for a different engine or a different sort of intake runner that obviously would not fit the Sentra. So I'm going to eventually fill this part in and obviously have the holes for the velocity stacks that will then attach down to the throttle bodies eventually. And this is not really everything yet, because I'm also going to have to extrude some of this out for vacuum lines that are going to be needed for the EGR and PCV stuff, as well as the brakes. I believe the brake booster needs the vacuum from either here or the velocity stacks themselves, so the velocity stacks may need to get tapped to have vacuum lines there. So there's still quite a bit of work to be done basically, but we're on the right track, and I feel like I'm making fairly decent progress on this so far. It's taken me kind of a while to learn Design Spark. I haven't really used CAD since my high school days, but in time I'm hoping I'll be able to kind of get the hang of this, and at the very least get this part built out so that I can get this 3D printed, and then hopefully we can do some testing. Now that's not really everything yet, because as you can see, there's a couple of things that are still needed for this. One of them being that we'll probably need a vacuum manifold to be able to pull the vacuum from the throttle bodies and then send that back out to whatever necessary components that will be needed. This will particularly be needed for the ITBs, as I believe I'll still need to tap them to send the vacuum for the brake booster. The rest will be handled by having the vacuum lines on the plenum itself. So hopefully when I build it, it will have a good enough seal that I will not have to worry about having these sort of vacuum lines leak or anything along those lines. The other important parts, of course, are that I'm going to need to have connectors for both the actual motor on the throttle bodies, which, if you haven't seen my previous video, they're BMW S1000RR throttle bodies that are entirely electronic, so there's no mechanical linkage. So that will need to be attached to whatever the kind of power lines are on the default kind of harness in the car. And to connect to the default harness, looking at a bunch of these kind of connectors, which I'm going to hopefully try a couple of them and see which one ends up actually fitting with the stock car harness. That way we will be able to get that connected up right and proper, and have the car kind of be able to stay stock, or stock looking at the very least, so that if you do need to change parts out, or if you want to go a different route, you'll be able to do that. And so again, I'm just kind of looking at a bunch of different connectors for that sort of application. As I look at it now, I don't think that the BMW throttle bodies will be something that will be able to go back in the bike, as they'll most likely need to be modified in terms of wiring to kind of accept the new connectors. But that wasn't really the plan anyway. They were always supposed to be kind of a test, so hopefully this will be fine. Now, as for regarding the actual TPS connector, that's one of those things that's still kind of up in the air. I'm hoping that I'll be able to find an actual connector that will fit it, so hopefully I will not need to do any cutting or splicing. If I do end up doing some cutting or splicing, then I would imagine that a connector like this I can put in between the stock harness and the way that it goes into the throttle body, and then basically kind of splice that in so that I could still connect the throttle body back using this connector, but then when I do need to disconnect it and connect to the BMW throttle bodies, we'll be able to just kind of unplug that and plug it straight into this particular harness. So there's kind of multiple ways of going about this, the way that I see it right now. Again, kind of going back to the actual airbox here, as you can see it's going to have a 3-inch inlet, so it's going to be perfectly good for the amount of airflow that the car is going to need. Later on, I'm hoping to give this more of a taper angle, as I believe, based on the CFD analysis that I've seen. Granted, I'm no engineer, but from what I've seen, the taper helps kind of distribute airflow more evenly to the individual kind of throttle butterflies, etc., through the velocity stacks. So that will be kind of the next step, but I think the sort of most important part is going to be getting this actual part tidied up so that we can get it printed and get it onto the velocity stacks, such that we can finally have this up and running. The other part that I have not gotten around to yet, but the part that I will be doing is once the velocity stacks are mounted up, I'm also going to see if I can create some intake runners that will be able to kind of bolt up to this. And the reason for the intake runners versus just mounting this thing pretty much straight onto the ITBs is because if we just mount this straight onto the throttle bodies as it is stock, basically all of the power, or I should say all of the torque is going to be towards the top end of the RPM range, which is not what you want on a streetable car. If I was making this as like a track only, time attack kind of car, then that would make, a lot more sense. But as it stands, I think for a streetable car and one that has more or less a close torque curve to what the original was, having longer intake runners down here, or at least as equal to the original length as possible, will kind of keep it in that same power band that it was before, while giving it better volumetric efficiency in terms of filling the cylinders with the proper amount of air and filling them more evenly. So we should still see, I would imagine, a little bit of a power gain. I don't think we'll see too much without a tune, but I think there will be some gains there because I don't imagine that the current kind of plenum setup is really designed for the greatest airflow. It's very restrictive, and they use pretty much oval and very bent kind of curves, so the air loses quite a bit of speed going through it. Now the intake runners, as I see it, will still need to be a little bit curved with this design because it still needs to fit under the hood, so that you're not having to cut into the hood of the car and have a hood bulge and all that kind of stuff. But it should keep the car in its optimal power band throughout the whole kind of rev range that we have based on the OEM specs. Now, down the line at some point, I was thinking of potentially going with a variable length of the intake runners, but I don't really have the mechanical design skills to be able to pull something like that off. And unfortunately, from what I've seen, there aren't too many kind of ITBs, or I should say too many velocity stacks out there that are actually adjustable in that way. Emerald is, I believe, the only company I've come across where you can actually vary the length of the ITBs, but obviously, velocity stacks, but those particular stacks are designed to be manually adjusted. So I guess depending on the course that you're going into, you would basically kind of unscrew the collar and then adjust the length as you needed to the specific torque curve you're looking for, and then basically kind of just let that go. But obviously, if you want this car to have kind of power everywhere across the whole rev range, then ideally what you want is the variable length runners. Now, obviously, as I was saying before, for me right now it's not really possible to do, but I would like that on the car at some point. However, right now the priority is just to kind of get this up and running and do a proof of concept, see that it's possible, and kind of see where it goes from there in terms of making improvements to the airbox and to the intake runners, etc., until I kind of feel like I'm satisfied with where everything sits. But in general, I'm thinking that with this kind of upgrade, one of the biggest issues with the car, which is the throttle response, should be solved. A lot of people have complained about this, and I've spoken at length about this in my previous video, so again, check that out if you haven't seen that yet. Basically, there's quite a bit of bogging that happens with this car. Some people seem to have it down low. I haven't seen that problem with my car. Where I do see it quite a bit is when you are already sort of at freeway speeds and trying to mash the throttle. So, for example, if you're trying to pass someone, all of a sudden the throttle response versus what you get down low seems to really suffer. And this is kind of dangerous as well, because if you're trying to pass, you really need to have your power come on early. And so this will kind of help with that quite a bit, I would imagine, versus the stock design with the single throttle body and the very curved, kind of intake runners that they designed primarily as a, packaging concern, because there was not a whole lot of space to really do anything else with that particular intake. And I think that with this design, given this will be front facing versus reverse or backwards facing as it is on the stock car, should allow for a little bit more flexibility in terms of what we're able to do here. Now, I'll still need to kind of size things up once I do get the part 3D printed to see how much length I can actually add to the runners without causing it to curve a whole lot, because again, I want to avoid the issue of slowing the air down as it has to pass through a bunch of piping, and obviously the longer intake runners are going to cause some of that to happen. And again, with the kind of longer version, we're going to be losing some power at the top, but hopefully because of, again, the packaging reasons, they won't be quite as long as the stock ones, so I think they'll still kind of move the power band up a little bit. So you're going to be getting more of that power a little bit later on down the rev range, which is, I think, fine with me. I would have preferred it a little bit down low since this car is kind of lacking on the torque side, but I think given that my next plan for my car specifically is to add the Phantom electric supercharger on here, that should make up for whatever kind of difference that this thing is going to make in particular. And there are a couple of other solutions that I'll detail sort of in my next video as a follow-up to this. But in the meantime, this has been my update, so kind of just keep track of this channel, keep track of the developments on this, and I'll see you guys in the next video where hopefully I'll have more of this kind of ironed out, so I'll have a bit more to show and hopefully do some preliminary testing with the wiring, and potentially having a kind of initial mounting to see where everything fits, and we'll go from there. So I'll see you guys in the next video, and take care until then.